Okay, so today we're going to talk about how to do assignment number 11100, and this can be found in the lecture and week 6 folder on Blackboard. And in week 6, it's named off 11100. We're actually doing on 11100. So what's the difference between off and on? Well, off is offline programming and on is online programming. So there is our blueprint right there. So it looks to me like we are going to output the X location, the Y location, and the diameter of 1, 2, 3 holes. We're also going to output the depth of all 3 of those holes as well. Now another thing that I'm looking at here, I see datums A, B, and C are the top plane, the front plane, and the left plane, respectively. So there are many different ways that you can do this. I'm going to show you the absolute simplest way for today. So far, all I've done is opened up Calypso. I'm going to close down some of these extra windows here. All right, and I noticed that I already have stylus system 3 by 50 millimeter. If I didn't already have that stylus system, I would go perform an automatic stylus system change, which is that A. I would left click on it, right click, and say load stylus, just as we've done in the past. All right, so I'm looking at our CMM tab, and I see that we have an online CMM. I see we have a stylus that has been calibrated. So the next thing we'll do is move over to the measurement tab. All right, so in the measurement tab, we will click on Base Start Alignment. That'll bring up a window that says Load, Create, or Change Base Alignment. And the default option is Create a New Base Alignment. So we'll say OK to that. So at the top of this menu, the name of the alignment defaults to Measurement Plan 1. Now you may remember in the past how whenever you went into the Run window and you tried to select an alignment, there would be a huge list of alignments. What I've realized is it's pulling that alignment name from whatever this is, and this is the default file name, which is Measurement Plan 1. So I'm actually going to rename this alignment Automatic Alignment. And I've started doing that for every single one of my programs. So that way I only have 4 things in my drop-down list in my Run menu. The first one is manual alignment, the second one's current alignment, the third one's automatic alignment, and then the software actually generates a 4th one automatically as well, which would be named automatic alignment, parentheses, CNC. So that'll just keep the list a little bit less cluttered. If it bothers you, it does bother me. I want to see only the things I need to see. Make less mistakes that way. So I like to name that automatic alignment. All right, and because we're online programming right now, we have the advantage of just looking at the part in the real world. So the first thing I'm looking at, is this part oriented correctly? Well, I see the 3 holes that I want to measure here. I see 1, 2, 3, 4 holes on the front face, and then I see a bolt hole pattern on the right face. It has a couple of counterbore holes and then a couple of drill holes. So that's how the part should be oriented. I'm also just feeling the part to make sure it's locked down. You don't have to lock these down crazy tight, just finger tight is fine. But I'm making sure it's not like somebody put it on there and it can still slide around. So your Allen wrench should be right here for that. All right, the next thing I'm going to do is start probing points. So I'll max out my speed here. And I don't want you to follow along with this at this time. I'd like you to watch the whole thing, and then you can try to duplicate it afterwards. All right, so I'm going to come over and touch 1, 2, and 3 points on my top plane. And over here, it opened up a dialog automatically that says Features. It started off as a point, then it turned into a 2D line, and now it says Plane 1. And that's exactly what I want. So So this is auto-recognizing the feature. This way of doing it is so clean, it's so easy, it's so fast. I'm just going to say OK to this. Now also, as soon as I say OK in my measurement plan base alignment window, it says spatial rotation is plane 1. That auto-populated. Right? Software's doing a whole bunch of thinking behind the scenes. Most of the time this is correct. For pretty much everything we're going to do in this class, it'll be correct. Another thing, it says Z origin right here, and that also auto-populated for plane 1. So basically what that's doing behind the scenes, it leveled the part out this way, it leveled the part out that way, and that's called the spatial rotation. It also set the Z origin to the top surface. So Calypso is doing all that thinking behind the scenes. Really cool. All right, now I'm back in the base alignment window, like I never left, and I'm going to come do my second feature. This is going to be a line on the front. We're going to measure from left to right. So when I first touch, the point window pops up, right? It says features point 1. We're going to come measure a point on the other side, and it automatically recognizes that as 2D line 1. I just say OK, and as of right now, the base alignment window does not have planar rotation X or Y populated. As soon as I hit OK, it populates planar rotation with 2D line 1, the one I just touched. It populates the Y origin with 2D line 1. So there's only one more thing I need to do, and that is probe a point on the left side. Now how do I know I'm probing the left side and not the right side? Well, that was driven based on the blueprint. Remember, datum A on the blueprint is the top surface, datum B was the front surface, and datum C was the left side. Now, as you go through some of the Curio Z content, you'll find that Calypso really prefers a plane, and a plane. And that does work just as well. In fact, that'll actually give you more precise results. What I like about this is it drives home the concept of a 3-2-1 alignment. And what a 3-2-1 alignment really means is you touch 3 points for your primary datum, you touch 2 points for your secondary datum, and you touch 1 point for your tertiary datum. Now, of course, those are all minimum number of points. That's going to be the theme with everything today. We're going to do the minimum amount of everything. It's not necessarily the technically correct way of measuring these things if you want to be extremely precise, but it's the fastest way of us getting some answers. You're going to find out how repeatable it is when you touch the absolute minimum number of points. And how are you going to figure that out? You're going to do a manual verification. This is great to know. As we progress through the semester, later on, we're going to learn that if you want higher precision, you have to touch more points or scan. We'll cross that bridge when we come to it. So notice that as soon as I say OK to this point window that popped up, it automatically populates my X origin here. So now our base alignment is fully completed. Now there's a whole bunch more you can do with this menu. We're not going to worry about that yet. We'll just hit OK. So notice that in the background, my base alignment has now turned green. So now I'm just going to work right down the measurement tab. Remember, when we started, we already did the CMM tab. Right? On the CMM tab, the CMM came in as green. It does every time you turn the machines on, because I've already set up everything on the machines. The stylus system icon started as red because your probes were empty. You did a stylus system change and grabbed the stylus, that turned green. Then we moved on to the measurement tab. Now on the measurement tab, our base alignment has turned green. The next thing is clearance plane. That's set to red right now. We'll click on that. That'll open up the clearance plane window. Now this window shows a little preview of the CAD model, and it shows in light blue the CAD cube that's around it. Right now, highlighted in pink and gray, there's a plus Z. So I'm going to drive the probe so that it's above the top plane, whatever I feel comfortable with. If you want to be about 100 thousandths above like this, that's fine. If you want to be a little bit more conservative and be an inch above, that's fine. This is probably a little bit too much for my taste, and I'm going to leave it here and set it just so you see what I mean when you see how the clearance plane works. So I'll press this little fire button, like for firing a missile or launching a missile. Launch button right there, and notice that that records my current Z position in machine coordinates. Then I'll move over to plus X. That has auto-advanced itself in the clearance plane dialog. So I'll come over to plus X. I'll move the probe so it's just to that side of the feature, and I hit launch again. Now it automatically highlights plus Y, and it's drawing a preview for me here on the screen. So I'll come over here to plus Y. Then it wants minus X. I'll come over to minus X. Now you see how it's only doing my X here, so I don't really care where my Z is when I do this. It's only looking for X based on what's highlighted on this screen. Press the button there, now it's looking for minus y. All right, those don't have to be super precise, just outside the part somewhere. Now, when you get more experience with this, you'll probably realize, hey, if I just move over here and hit beep, beep, beep 3 times, and then I move over here and I hit beep, beep, beep 3 times, that works as well. Whatever you want to do, let's make a difference. Now, Calypso doesn't actually use its minus Z clearance plane at all. I usually don't set the minus Z clearance plane because I don't want students hitting this sensor on the part itself. Right? This is 15 grand from here to here. If you hit it, you will break it. So there's no need to set the minus Z clearance plane. Again, software doesn't even look at the minus Z clearance plane. It won't pull you off in the Z anyway. So don't worry about setting the minus Z. The minus Z will come in automatically if you're programming offline using CAD. In fact, when we do this offline using CAD, there's another window that shows up here that says clearance plane from model. It's beautiful. You just click on it. It does all that automatically. All right, so I'll say OK here. And it says update clearance plane settings for defined features. You're always going to say no here. I'll spare you the explanation on why, but that dialog is really meant for when you're using star probes. We're not even using star probes in this class. Maybe we'll have time to get to it, probably not. All right, so our clearance plane is now set. You see how it's turned green. Now we have multiple report. We're always going to leave the default there. We also have measurement plan editor features. That allows you to mass edit features. We don't have any features yet. We're not going to worry about that. And then we have temperature compensation. We don't have the ability of adjusting our temperature compensation on these machines. CurioZ has a module on that. I don't know if you've done it already or not, I forget. But it'll explain what that is. Basically, parts grow when it gets warmer, they shrink when it gets colder. That is important when you're talking about tenths or thousandths of an inch, right? Sometimes a big part with a huge temperature swing that's made out of aluminum will grow a couple of thousandths if you're going, 30 degrees difference. If it's 90 on the manufacturing floor, 95 degrees versus 68 degrees as the agreed upon temperature, that will make a big difference. We're not even going to worry about that. So what do we do on the measurement tab? We basically do base alignment and clearance plane. That's it. All right, now I'd love to say we can continue to go systematically and just move over to the characteristics tab, but you can't really do any characteristics until you have some features to work with. So we're going to bounce over to our features tab here. And you notice that I already have features for plane 1, 2D line 1, and point. Those features are really my alignment, right? So here's something that I like to do. I'll hold shift, click on the top one, click on the bottom one, and then I'll right click and I'll say form group. And then I'm going to right click on that group and say rename, and I'm going to rename it automatic alignment. Because is there ever a time when I want to run part of an alignment without the other part? Not really. So grouping these features together is something that you'll see in the videos that I'm putting online. I group my features. And if you ever get to a star probe, you'll find that that is hugely helpful, because a lot of times you want to group all your features measured with this into one section of the program, and all the features measured with this into a different section of the program, so on and so forth. Also, your programs will get huge. So it makes it a little easier to read by being able to collapse it. So making it a group is a nice thing to do. All right, very nice. So what else do we have to measure about this part? Well, let's take a look at the print. Have we done datums A, B, and C yet? Yep. So the next thing we should do is really balloon our print. Now, since I made this print in this assignment, I realized that I don't want everybody ballooning their prints differently. I want you to know how to balloon a print. I want you to have practice ballooning prints. But when I'm grading, it takes way longer if you balloon your print one way and you did it a different way and you did it a third way. So I'm okay with however you do it. But for these, I want them to be homogeneous. So I'm going to update this with some balloons on it. And if I'm not mistaken, with this particular one, I started here and went I went clockwise around this view when I ballooned. So this would be balloon number 1, balloon number 2, 3, 4, 5, and 6. Right? I'm seeing a hand back there that's saying, no, 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 I like to go counterclockwise. Sure,
No,
that's fine.
I think that's the way you go. So 1, 2, 3, then 4, 5.
Yep.
Yeah.
So everybody does it a little different. That's fine as long as it's systematic. So the reason you want to balloon this print to start, and the reason I'm going to release a ballooned print here, so that way everything's homogeneous and we can go systematically. But it looks to me like we're just doing XYZ position of these holes. Now, usually with a circle, you can only check the X and the Y position. And if you have a drilled hole, it's not easy to touch the bottom of the drilled hole and see how deep it is, because there's a drill point in the bottom of it. But if you look at these holes from a top view, or if we look at the front view here, we can see the dotted lines that show they're actually flat bottom holes. So when I say we're going to check the XYZ position of the hole, I mean we're going to touch a circle, and that's going to give us the X and the Y position. And then we're going to touch a point at the bottom. And the only reason we get away with that is it is a flat bottom hole. When we touch the point at the bottom, we'll output the Z position. The last thing that we have to output is the diameter of all of these features. And the diameter of all of these features comes along for the ride when you touch a circle. So what do we have to do? We basically have to touch a circle in here and a point at the bottom, and a circle in there and a point at the bottom, and a circle in here and a point at the bottom, and the rest is just making characteristics. So let's go do that. So this is so slick when we do this online. If you're looking for a low precision hole, all you have to do is drive into the approximate center of the hole, slow your speed all the way down, and hit the pull down on features, and come to circle with 4-point macro. Click on that. It'll ask you, is your selected probe in the center of the circle? Say OK, and then you can speed the dial up to get to a reasonable speed. You do not want this speed dial to be maxed out for this. It'll be very aggressive when it hits the hole. Remember, it doesn't know how big the hole is when you're doing this.
And what button were we pressing on there?
You slow your speed all the way down, and to get there, we went to features and 4-point macro. It gave you a dialog. You just hit OK. All right, now as I'm doing that, it opened up the strategy window automatically. And then it added 4 probing points automatically. So I'll just say OK. It also adds them to the graphics screen here. It also opened up the features window behind the scenes. That was actually the first thing it did. It opened up the features window, and then it went in and automatically opened up the strategy window. We added things to the strategy by touching points, and then I closed it. Features window is still open. Now this is a cool thing about direct features. This is a direct feature right here, meaning the X, Y, and Z locations all come from the origin. This almost never happens on a print, but it's a really easy way of creating a program, and that's why we're starting with this. So these are all called direct features. If you have a direct characteristic, you can output it in this menu. So right here, it's the feature menu. It says circle 1. I'm going to ignore everything else about the menu except for where it says X, Y, Z, and D. Now, do we care about the X position of this hole? Remember, we have a cylinder in the part, and we just measured a circle using 4 points on the cylinder. So yeah, the X location of that is important. How about the Y? Yeah. How about the Z? No, the Z depth is not actually on the part at all. The Z depth is just wherever I put the probe. The bottom of the hole is down here. I measured those points up here somewhere. So no, that's not helpful. So I'll check on X, Y, and D. And don't worry, we can always come back and do this later. Right? If you forget to do it now, no big deal. But while we're here, because this is so easy, we'll do X, Y, and D, and then we'll come back here, and we'll figure out our X location for this. It'll be 1 inch 512. So that came in at 1 inch 504. Why did that come in so far off? 1 inch 504. Who says that's actually 1 inch 512? When you program this in CAD, it'll probably come in at like 1 inch 511.9 or something like that. It'll come in very, very, very close. But this didn't grab the correct number by default, so I have to type that in under the nominal. The actual is set to 1 inch 5047, and I bet you when we do the manual verification on this, that hole really is 1 inch 5047. The only thing that would really cause that to be wrong is if this probe was not calibrated. Well, right before we started this, we just calibrated the probe, so I pretty much trust that. We'll still verify, but I pretty much trust it. So you have to be very careful when you're doing this type of programming. Yes, this is online programming. Another word for it is called teach-in programming. We're teaching the machine what to do right now. It's quick, easy, simple. but your nominals kind of come in wrong. And also the software is just guessing at whatever your upper and lower tolerances are. What's our upper and lower tolerance for the x? 3-place decimal, plus or minus 5. So we have to input that as well. So now you can see why I say, yeah, you could set the tolerances right now, but for me, my workflow is usually I create all the features first, and I go back and do the tolerances after. And the reason is when I'm thinking about how to measure features, I'm thinking about the most efficient way to get from one feature to another. I'm just thinking about all the information I need to get. And then I figure out what goes on the report afterwards. So, you know what, we could fill all this out right now, but I'm almost losing my train of thought by doing that. I'm gonna uncheck those things and just say okay. And now there's the circle just sitting there. And if we look at our characteristics window, nothing has been added there. If I had decided to go through with that and I checked on the X and the Y and the D, notice that in our characteristics window, that added those behind the scenes for me. Right? So you can choose to either output characteristics now or output them later. It doesn't really make a difference. I'm going to choose to output them later. So far, I've touched one circle. Now, I also need to touch the depth of this hole as well. And I said we were going to do that just with 1 point. So for that, I will simply drive down. It comes up with a point. Now here's where it's so tempting to just turn on Z and set the nominals and the tolerances. And for direct features, you could. I could do that right now. But I'm going to try to stay on kind of a one-track mind here, and I'm just going to go measure more points. So I measured the point for the first hole. You notice I retracted that automatically just because I know the next location I'm going to is going to be this hole. So I'm coming into the hole. I'm going to turn my speed dial all the way down. And then I'm going to come into the features pull down and go to circle with 4-point macro and say OK. That opened up the feature window and the strategy behind the scenes. Now here, if you look at where my speed dial is, I mean, if that's off, I only turned it to about here, and that was going relatively quickly. So you do not want this speed dial to be at full speed when you do this. All right, so I just touched my circle with 4 points. Boom, it gave me my points. I say OK. That brings me back to my features window, which was created automatically. I hit OK there as well, and my circle shows up in my features tab. Again, if you wanted to set your characteristics at that point, you could have. Now I'm going to go touch my point. So I'll come straight down. The point window comes up automatically. I just say OK. Now you notice when all these features are coming in, they're colored green. And that's because Calypso has everything it needs about these features to be able to generate a dimension report right now. When you do this offline, these will often come in as gray, meaning, yeah, I know what I need to measure. I know how I need to measure it. However, I haven't actually measured it yet. To get them to turn green, you have to actually run the program. All right, we'll come over to our last hole here. And you do want to be pretty close to the center when you do this, otherwise you'll get some weird, funky normal values. In fact, I'm going to move a little off-center for this one just to show you what I mean. Let the features pull down, slow it down, go to 4-point macro, say OK. And I don't know if you can see it from where you're sitting, but I was over here when I started, so it touched here, it touched there, and then it came back over way offset and touched here, and that will be captured in the program as well, and that will cause some slight errors in the size of the feature. And we'll probably, that one is bad enough that we'll probably even see that when we measure it with calipers for manual verification. So again, this is the quickest and easiest way of doing it, but it's not necessarily the best way of doing it if you want to get accurate, repeatable results. All right, when you do this with CAD, the CAD model will pick up all the normal vectors automatically, so you won't have that issue of measuring things slightly off-center. All right, so we measured the circle with a 4-point macro. We'll say OK to those two windows, and then we'll come over, touch our point at the bottom. And then we'll hit OK. All right, and our program is now done. We'll submit it, right?
Yeah.
Don't you approve it?
Yeah, we have a couple more steps we have to do here. So that's what I call the fun part. Now we have the detail-oriented part that nobody wants to do, but this part is what they actually pay you for. So first things first, when I was creating those points, I was kind of assuming that they were being added to the end of the list. And normally they would be added to the end of the list. But I clicked somewhere before, I think I clicked to reopen the circle, just to show you that I could open it up. And when I clicked like that, the highlighted bar was right here, so it kept adding my features in out of order. So now my features are out of order, and let's click on them and let's take a look on the graphics screen to see which one's which. So if we open up our automatic alignment, we can see plane 1 is the top plane, the line is the next line. So rather than clicking on these, a lot of times I like to just arrow down here. I find that's a good way of doing it. That point over there is our point on the left side. This right here is our first circle. Then we have a point at the bottom of that circle. And then we have a point over here next. And then a point over here next. And then this circle. And then that circle. So what would happen if we just ran it like this? Well, let's go ahead and run it like this. Do you think that's going to cause a crash because it's jumping back and forth in between the two of these?
Well, you say your clearance already.
I'm assuming it works.
Should it clear? Well, let's figure it out. All right, so we have a couple of different answers there. So I'm going to hit the run window. And for this, I'll say clear existing results. I always start with that, otherwise you don't have all your options. We're going to accept our default PyWeb reporting. Now here we could do manual alignment, current alignment, or automatic alignment. Which one do we want? What are the differences?
Automatic. Go to current.
So manual alignment means we're actually going to touch the part to find it. We already found the part today, right? We haven't moved it since we found it. Okay, current alignment will ignore the alignment. Current alignment is only for, well, actually, pretty much exactly this scenario. In this scenario, I did just do an alignment, and I haven't moved the part at all. If I tap that ever so slightly, current alignment no longer applies. And current alignment is simply going to take the alignment you already did and ignore the alignment features and just go measure the features that you want. That's kind of a highly specialized thing. We very rarely use it. I'll use it when I'm programming and I'm midway through a complex program and I just want to measure just that one feature to see how it worked. Then current alignment's helpful. In fact, it even kind of warns you in the software. It colors it yellow. It's like, are you sure you want to do this? So in this case, I'm going to say automatic alignment. I want to see how those features will be measured in the real world to make sure I'm in the right spot and all that jazz. So automatic alignment. Now we have some options underneath that. We can do all characteristics or current selection. Let's try all characteristics first and see what happens. All right, we'll go from features list. We want our order of run to always be from features list because we make our features list path efficient. That's the most efficient cycle time is our features list. You could run it from characteristics list. That'll just take the order from this list instead of that list. Clearance plane, slow through first feature. We'll switch that to step mode. We've never run this before, right? And it turns out that in this speed dialog, you can actually type a number. So my new thing is I just type the number 55. Why? I don't know, 50 millimeters a second is about right, and just hit the 5 twice. I'll slow this down and I'll hit start. Then I'll hit continue. And this comes over and starts measuring that first plane. So does this look about right based on what I expect to see? Yeah, looks about right to me. Well, now we see that high clearance plane is probably higher than we need. So it doesn't hurt anything to have a clearance plane that's that high, but when we start measuring these circles, I think you'll find it's pretty cumbersome. All right, so we did our alignment. Something pops up that says info on the run. You can always make this pop up again later. I like to uncheck any of these boxes down here because I don't want to see that. I pretty much know what happened just by watching. I'll just hit close. And now I'm looking at an empty characteristics list here. So that just ran the alignment. It didn't run anything else. What's going on with that? Well, if we come over to our features list, we hit run. Oh, notice that for selection, I had all characteristics selected. I told it to do the automatic alignment, so it did. But do I have any characteristics right now? No, I don't have any characteristics. This kind of drives me crazy. So what we really have to do here, we want to select everything from this list. I'll hold shift, I'll click on the top, hold shift, and click on the bottom, and then I'll hit run. This is what I was showing you on day 1 of class, or day 2, or whatever it was. Instead of doing all characteristics in this specific instance, I'm going to say current selection, and I've intentionally selected all of my features. We're just going to watch it run. And I'm still running this in step mode. So I'll hit start. And this is going to come back and rerun our automatic alignment again. Do we really want to? I just ran the automatic alignment. I haven't moved the part at all, right? That's why current alignment exists in the software. All right, so we're starting to see, even though that run window has a ton of stuff going on and it seems complex at first, when you start actually running programs, you need every little bit of that functionality. Right? In fact, if we removed any of that functionality, you would probably say, hey, it'd be nice if Calypso had a setting for blah, blah, whatever it is. All right, so now it's coming over and it's going to measure those circles. So why did it do this? Well, I said I want to execute selected features. I had every single feature selected. Okay, now why is that moving all the way back up after the circle before it measures that point? This
So we recorded your clearance plane?
That's the clearance plane. The clearance plane happens at the beginning and the end of every feature. Now, is that the end of the world? No, but is that a pro level move to be doing that? No, it's amateur hour. Now, why did that went and measured a point, and then it went over to the other circle and measured a point. Now it's coming back to the first circle and measuring a circle. Then it's going to go to the other one and measure a circle. So is that path efficient?
Not really.
No. Again, does it work? Yeah. Is it the right way of doing it? No, that's kind of amateur hour. Again, still. So how do we fix the ordering of that?
Can you just realign it in the tab?
It's easy. We just pull them out to whichever order we want, right? So we can just pull things in the feature list into the order that we want so that it's path efficient. So even if you didn't measure things initially path efficient, don't worry about it. You can do that later. So now you're starting to see why my workflow is just touch the things. Don't worry about it too much yet. Touch all the things you need based on what you see on the balloons. Then you can come back in and reorder them. We can fix that clearance issue where it's going up and down later. Right? Just touch it all first, and then we'll clean it up. So here it looks like it should go circle 1, point 2, then it should go circle 2, and then point 3, and then circle 4, and then point 4. Now you might also be saying, hey Tom, can't you just double click on that and rename these features so that they make sense? I love the idea of that. In execution, that will mess up your workflow entirely. If you're spending your brain power trying to think about what you should name these features at the feature level, you drive yourself crazy. That's just my opinion. So I don't bother renaming these features. I just let them be whatever they are, because if you ever have to look at the features, you're looking at the graphics screen as well. It tells you what it is. These features are not seen anywhere else. The only thing that the operator ever sees or the inspector ever sees is the dimension report. And the feature names, they're not included on the dimension report. All right. So let's run that program again. I'm going to hit run. And actually, you know what? I made a mistake here. I only have circle 3 selected, right? So if I hit run and I leave this on automatic alignment, it's going to go do the automatic alignment. And if I say current selection, it's just going to come over and measure circle 3, and I'd be sitting there scratching my head. That's why I'm going bald, right? I'm scratching my head trying to think out what happened. It's Calypso's fault. And my kids. My kids are doing it as well. This one is my daughter, and that one's my son. That's what I think.
During competition?
Yeah. So we got to pay attention to this. I kind of don't want to do that alignment again. I just want to see whatever I added to it. The alignment is the alignment. It's fine. So let's hit the pull down, and let's go to current alignment. And then I could say all characteristics, but I don't think that would do anything, would it? I don't have characteristics yet. Then you might say, but the order of run says feature list. Yeah, it's only the order of the run. Whatever it's actually measuring is driven by this, by your selection dialog. The order that it's doing it in is driven over here by your order of run. So let's do that. Let's our current settings are current alignment, all characteristics, and clear existing results. So I'll hit start. We don't see any, well, there are no characteristics. Of course it didn't do anything. I told it not to do the alignment, and then I told it output all, just go touch all the things you need to get this information. There's nothing there. All right, well now I still have circle 3 highlighted, and I'll hit run, but I'll say, you know what, I'll show you. I'm gonna say measure your current selection, and start. And now it actually does something. Now it comes in and measures this circle. Why is it measuring this circle then? That's what I had selected. So if I want to measure the entire program but not the alignment, the only way to do that is to highlight everything that is not part of the alignment. So we'll click on the top, we'll hold shift, we'll click on the bottom, we'll hit run, we'll hit current alignment, current selection. The rest is still whatever it was. And now when we run this, I mean, we've already run this, so I'm going to say switch to CNC run. You notice I took my hand right off the speed dial? I haven't changed anything, so. I did change the order of the features, but these features are all on the same plane, and we know that the clearance plane, or we know that the probe's going to go to the clearance plane at the beginning and the end of every feature anyway. So is this program running more efficiently now? Yeah. That clearance plane is really just driving me crazy. It's because if you've done any amount of CNC programming in your life, you know that airtime is obviously not a good thing. It's the same thing here. But did our program acquire all the information it needed? Yeah, sure did. All right. So the last thing we have to do is output tolerances. Now we can come over to the characteristics tab and we can hit the size standards, and we could do X, and we could double click on it, and we could come in and select the feature for circle number 1, and we could do all that jazz. Man, oh man, that was a lot of clicking, right? Because these are direct features, we can just go to the features menu and double click on the feature itself. And we said for circle number 1, which is the feature I opened, we want to output X, Y, and D. Yeah, we could go update the nominals and the tolerances, and we should at this point. But at this point, I just want to get you on the machine's programming, so I'm not going to bother filling all that out. Again, this is the part that is painful, and this is the part they pay you for.
So characteristics are only start creating when you click on the X and the Y and the Z or whatever?
If you have a direct characteristic, you can output it directly from the feature menu. If you have an indirect characteristic, which we're going to learn about next week, then you have to create that from the characteristics menu, not the feature menu. A perfect example would be if we were measuring from this hole to this hole, but our origin's over here. Our distance doesn't start at the origin, so we can't simply output an X coordinate. We have to know what are we starting from and what are we going to. That's called an indirect characteristic. Don't worry about it too much now, because we'll talk about it next week. All right, so because these are direct characteristics, I can just go through for point number 2, which is at the bottom of this hole. We really want to output the Z, correct? So notice as I'm clicking on these things, it's adding them to my characteristics list in the background without saying anything. All right, I come back over to my features tab, circle 3, I can see is this circle. What are we going to output with circle, that's circle 2. What are we going to output with circle 2? We're going to output our X, our Y, and our D, right? We can find where the hole is this way. We can find where it is that way. We can see how big it is. So the circle is going to be X, Y, D. Point number 3 is at the bottom of that counter bore. What are we going to do with that? Double click on it. Click on Z. Say OK. Circle 3 is back here. What are we going to output with circle 3? X, Y, and D. And then point 4 is at the bottom of that counter bore, or flat bottom hole. For that, we're going to output our Z. Now again, we should have updated the nominals and the tolerances there. Let's say we forgot to update the nominals and tolerances. Well, we can always come back in the characteristics list. We can double click on them, and we can update them here at this time. So one thing that's really nice about this software is nothing is set in stone. Now let's go back and run the same thing again. Notice that my characteristics all came in with either green or red bars. That's because we've already acquired the information we need to output those. We've already touched the points on the CMM. Another way to think about it, we made a point cloud. We have a cloud of points over there. This is what tells the software how to process that information. The characteristics tab takes that point cloud that we generated, puts it into usable information. So if we want to make our dimension report, all we have to do is come over to our features tab and hit run. And for our selections here, we'll just uncheck clear existing results. What clear existing results really does is it wipes that point cloud clean. You only get one list of existing results that the computer is keeping track of. When you start touching points, it's remembering those. If you turn on clear existing results, wipes out the point cloud. It means it has to go measure some stuff to be able to output characteristics. Right now, I'm not telling it to wipe that point cloud clear. I'm telling it just do all the characteristics you can, and I'll just hit start. I see the little cursor is going beep, 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 beep. The machine doesn't move. For me, when I was learning the software, that was the most frustrating thing. That clear existing results checkbox changes everything that's happening. Once you know what you're doing, it makes perfect sense. Before you know what you're doing, it's like, when do I have to check this on? When do I have to check it off? When you check on clear existing results, your point cloud is gone. You're starting from square one. Yeah, your features are still there. It knows what to do, but it hasn't done it yet. Your characteristics are still there. It knows what it should put on the dimension report. It doesn't have the point cloud yet. So clear existing results means you're going to have to measure a bunch of stuff. If clear existing results is off, it takes what it already knows, and if there's a mismatch between what it already knows and what it needs to know, it will simply do whatever it's missing, not the whole thing. So that's kind of cool. I closed out of my dimension report, or it didn't open up. What do? I hit view and multiple report. And there's my report right there. So as soon as I look at my report, I notice that my characteristic names are not tied to the blueprint in any way. It'd be nice if this was named based on balloon with a description on it. So this first feature really should say B1 underscore hole 1 underscore X. Right? It's balloon 1, it's hole number 1, and it's the X value of hole number 1, or whatever it is. I have to go back in and I have to update my nominal value. My nominal value did not necessarily come in correctly. I also have to update my tolerances. Now, if you decided to update the nominals and the tolerances and the feature names earlier on when I said you could, you don't have to do that at this time. But if you use the workflow that I use, where you touch all the features first, then you output your characteristics afterwards, and then you go back and you review them for correctness at the end and modify as necessary, it's probably going to be the path of least resistance. Right, so yeah, I still have some editing to do here, but all the rough structure of the program is there. If I just give this to somebody, is that going to be useful? I mean, I guess so, but it's going to be really hard for them to go figure out where that is, and these greens and reds don't mean anything yet because I haven't updated the nominals and the tolerances. Right? Again, that's why I say what they pay you for is the detail work. The detail work is updating the names, the nominals, and the tolerances. All right. So that's it. That's your whole first lab. So we're going to do this in person online here today. And then you're going to do pretty much this exact same program, but you're going to do it offline using the CAD model for homework this week. Next week, when you come in, you're going to prove out the program that you wrote offline. So in theory, all you have to do is come in here and press go, do a manual alignment and hit go, and everything should be great. And then we'll program the next lab, which talks about indirect characteristics online. And when we're done with that, you'll do the same program offline again. It's going to be that for the rest of the semester. All right, so let's get to it. All right, so you are all set.